All right, this video is going to be going over notes 8.5. This will be angles of elevation and depression. So this will be the last day of notes that we go over involving trigonometry. And the very first thing we want to take a look at is something known as angle of elevation. What I want you guys to understand about angle of elevation is that an angle of elevation is the angle formed by a horizontal line and an upwards line of sight. So angle of elevation, again, is an angle formed by a horizontal line and an upward line of sight. So here's our horizontal line. And then our upwards line of sight is, look at this eyeball. This is your observer's eye. This eye has an upwards line of sight looking at this object right here. So angles of elevation are formed by looking up, and they're formed with that upward line of sight and a horizontal line. Angle of depression, on the other hand, angle of depression is the angle formed by a horizontal line and a downward line of sight. So you'll notice here that our angle of depression is going to be formed with here's our horizontal line here in blue, and it's formed with a downward line of sight. Okay, so that angle of depression here would be represented by theta. So this right here is your angle of depression. Okay, so this is really important. I know I'm repeating myself a lot, but it's because I want you guys to remember the difference between these two. So angle of elevation is formed by a horizontal line and an upward line of sight. So here the theta represents your angle of elevation. On the other hand, an angle of depression is formed by, well, it's also formed by a horizontal line, but angle of depression is formed with a downward line of sight. So it's like we're looking downwards. Okay, so let's actually take a look at some important relationships that happen with elevation and depression. So, one thing we want to take a look at here is that angles of elevation and angles of depression are formed by horizontal lines and lines of sight. So, they have that in common. Both must be formed with a horizontal line and some kind of line of sight. And so, one important thing that we're going to realize here is that the angle of elevation from one point is actually going to be congruent to the angle of depression from the other point. So, take a look at what we have here. This is basically what this second bullet point is saying. It's saying that this angle 1, the angle of elevation, will be congruent to the angle of depression from the opposite point. And the reason why we have this congruent relationship is because, well, take a look at these horizontal lines here. If we take a look at these horizontal lines, what you'll notice is that this green line represents a transversal. The reason why these are congruent is because the relationship between angle 1 and angle 2, going back to what we learned in semester 1, well, these angles are both on the interior and they're on alternate sides of the transversal. So we're going to notice here that angle 1 is congruent to angle 2 because they are alternate interior angles. So that is the reasoning behind this. And so that is going to be an idea that we're working with whenever we're drawing our pictures and working with angle of elevation and depression. Please make sure that you understand your angle of elevation is congruent to the angle of depression from the opposite point. Okay. So the next thing we're going to take a note of here is that the angle of depression is going to be complementary to the angle adjacent to it. So we'll see this pop up here in the notes, but realistically, we're going to be working with this second bullet point for most of the problems that we look at here. So this will make more sense as we start to see some examples. So as we see some examples, you're going to start to see this vocabulary pop up. You'll see angle of elevation or angle of depression, something along those lines. So let's read example 1. It says a ladder is leaning against a wall in such a way that the tip of the ladder is touching the tip of the wall. The bottom of the ladder is 13 feet away from the base of the wall. If the angle of elevation at the bottom of the ladder is 51 degrees, then how long is the ladder? So with these word problems, you are always going to want to draw a picture. So for this first one, they were nice enough to provide a picture for us. All we have to do is label it. So we have a ladder leaning against a wall. Here is our ladder leaning against a wall. And it says that if we're going to begin to label here, the bottom of the ladder is 13 feet away from the base of the wall. The base of the wall is the bottom of the wall. So the bottom of the ladder, here's the bottom of the ladder, and it's telling you that the bottom of the ladder is 13 feet away from the base of the wall. So we can label this bottom side as 13. And the next part says the angle of elevation at the bottom of the ladder is 51 degrees. So I'm looking at the bottom of the ladder. Angle of elevation, remember, angle of elevation is formed with a horizontal line and an upward line of sight. So our angle of elevation here, here's our horizontal line and our upward line of sight. This angle of elevation, they tell you, is 51 degrees. And then lastly, what they want us to find here is it's asking how long is the ladder, right? How long is the ladder? When we're looking at this triangle, the ladder represents this side right here. So we want to find the length of that ladder. We're going to call it X. Now, one thing that'll be left for you to do in these problems is to label your right angle, right? Right angles are going to look like this. They're going to be perpendicular. So you'll see a right angle happen whenever you see a picture that's drawn in that manner. So our right angle is going to be located right here. So what we're working with here is a right triangle, and we want to find how long is the ladder. So we can use trigonometry to help us find how long the ladder is. So if we're working with our angle of perspective of 51 degrees, this represents your opposite, this is your hypotenuse, and the 13 represents your adjacent. If we begin to look at what we have, we're working with x, which is the hypotenuse, and 13, which is the adjacent, okay? I'm going to write this here at the top just for reference to help us figure out which trigonometric ratio we're going to use. We're going to talk about SOHCAHTOA. So what we're working with here in this problem is we have hypotenuse and adjacent. So I'm going to find hypotenuse and adjacent. That's going to be this one right here. So what we're working with here in this problem is cosine. So let's set this up. Remember that cosine of theta is equal to adjacent over hypotenuse. So if we're going to plug this in, then what we're working with essentially is going to be, well, let's plug it in. We have cosine of theta, which is the angle of perspective, well, cosine of 51, is equal to, well, adjacent over hypotenuse would be written as 13 over x. And there's our setup. The hardest part for these problems is drawing the picture and labeling it and setting up your equation correctly. That truly is going to be the hardest part for these problems. So now that we have this set up, we want to find the value of x. If you have me as your teacher, Mr. Barbie, what I told you guys to do is put the left-hand side of your equation over 1, and now we can cross multiply. If we cross multiply here, 1 times 13 is 13. And then x times cosine of 51 is x times cosine of 51. What we need to do now is we need to solve for x. If we want to solve for x, right now we have x times cosine of 51. We need to cancel the times cosine 51. So we're going to divide by cosine of 51 on both sides. Doing so cancels this out. And now what we have is the x by itself. Now we see that x is equal to, well, 13 divided by cosine of 51. So that would represent your exact answer. That would represent the value of x. We just have to type this into the calculator to see what we get. So I'm going to pull up our calculator here. We have Desmos as our calculator. Make sure that when you're doing trig that you're in the correct mode. The mode that we need to be in is in degree mode. So I'm going to go to our settings here. I'm going to scroll down to the bottom and make sure that we are in degree mode. And now I'm going to go ahead and type in what we have. 13 divided by cosine of 51. So 13 divided by cosine of 51. If we type that in, what you get here is 20.65720447779. What we're going to do is round to the nearest 2 decimal places. If we round to the nearest 2 decimal places, we're going to look at the number that follows. So this number is 7. This means that the 0.65 is going to round up. So this is going to be approximately our value of x is going to be, let's pull that back up there, Approximately, we're looking at 20.66. This is going to round up. So 20.66. That is our value for x. And to answer the question, how long is the ladder? We're going to write a complete sentence here. The ladder is about 20.66. And then we want to check the units. What are the units here? Inches, feet, what are we looking at? I'm going to look for a number here. It says 13 feet, so we know we are looking at feet here. So the ladder is about 20.66 feet. And so that's how we're going to use trigonometry to answer these word problems. Today's notes is all about word problems and understanding what it means to have an angle of elevation and an angle of depression. So you will feel more comfortable with these with the more problems that you practice with. So let's just keep practicing. Let's look at another example. Let's look at example 2. Example 2 is missing. Let me make sure that I get example 2 up here. Let me just add this really fast. We're looking at our notes here. Example 2 is going to be this one. This one is missing from my notes. Let's get this copied over real fast. So here's example 2. It says a plane is flying at an altitude of 12,000 meters. From the pilot, the angle of depression to the airport tower is 32 degrees. How far is the tower from a point directly beneath the plane? So a lot going on here in this word problem, and we have the picture. All we have to do is just label the picture correctly. So why don't we start with the first part? It says a plane is flying at an altitude of 12,000 meters. Okay, you'll notice that for this particular problem, we have one picture with a check mark and one picture with a red X. I'm going to show you the correct way to label your picture, and I'm going to show you the incorrect way or the wrong way to label the picture. So let's go ahead and start by labeling what we know. Plane is flying at an altitude of 12,000 meters. Altitude is another word for height. Height is looking up and down. So your altitude here for the plane is 12,000. Okay, so I'm gonna label both pictures here. We got 12,000. And then it tells you that from the pilot, the angle of depression to the airport tower is 32 degrees. So from the pilot, pilot is going to be the person that's driving the plane or flying the plane, I guess I should say. So from the pilot, so from the plane, the angle of depression to the airport tower, here's your tower, that angle of depression is 32 degrees. Now, this is going to bring us back to our definition for angle of depression. Look at angle of depression. Angle of depression is an angle formed by a horizontal line and a downward line of sight. So if I go to our picture, the angle of depression is formed with a horizontal line. I'm going to highlight here so you can see what I'm looking at. Angle of depression is formed with a horizontal line and a downward line of sight. So the angle of depression of 51, I'm sorry, not 51, 32 degrees here needs to be located in this spot. That is where your angle of depression should be located. One of the most common mistakes that we see students make is that they put the angle of depression inside the triangle right here and they say that, oh, that's my angle of depression of 32 degrees. This is wrong. Your angle of depression must be formed with a horizontal line and a downward line of sight. If we look at this angle here, this angle is being formed with a downward line of sight, but it is not, I repeat, it is not being formed with a horizontal line. It's being formed with a vertical line. That is wrong. Your angle of depression is with a horizontal line and a downward line of sight. So now that we have this labeled correctly, what we're going to use is what we talked about earlier. What we talked about earlier was that the angle of elevation and the angle of depression from the opposite point are congruent because they're alternate interior angles. So we're going to use that to our advantage here. What we're saying here is that if this is 32 degrees, then this angle here must be 32 degrees because they're alternate interior angles. And so if we keep reading, it says, how far is the tower from a point directly beneath the plane? So how far is the tower? Here's our tower. How far is it from a point directly beneath the plane? Here's our point directly beneath the plane. They want to know how far is this distance. We're going to call that x. And so now we have our picture labeled correctly, where we're going to have our right angle located here. Okay, so Just be very, very careful labeling your angle of depression. This is the correct way. The picture on the right is the wrong way to label it. So here's what we have. To make this a little bit easier to read, I'm going to pull out this triangle from that picture. In this triangle, we have this vertical side is 12,000. The bottom side is X, and this angle here is 32 degrees. Okay, looking at this triangle that we have here. So looking at using trig here, well, this is our angle of perspective. This is our hypotenuse. We always label hypotenuse first. This is our opposite, and the bottom side represents the adjacent. So in this one, we're working with opposite and adjacent. If we're working with opposite and adjacent, when we're looking at deciding which trig ratio we're going to use, remember we're looking at SOHCAHTOA. So if we're working with opposite and adjacent, I see opposite and adjacent right here. We're working with tangent. So let's set up our equation. We're looking here at tangent of theta is equal to opposite over adjacent. What we're going to do now is plug our values in. So we're working with tangent of theta is the angle. The angle that we're working with is 32. That's equal to opposite, which is 12,000 over x, the adjacent. And so here, if we're going to solve for x, we put this guy over 1 and we cross multiply. Cross multiply, we get x times tangent of 32 is equal to, well, 1 times 12,000 is just 12,000. All right, so we want to solve for x here. If we want to solve for x, x is not by itself. We have x times tangent of 32, so we're going to divide by tangent of 32 on both sides. Doing so cancels this out, leaving you with x is equal to 12,000 divided by tangent of 32. All we have to do now is plug that into the calculator. So pull our calculator up here. We got 12,000 divided by tangent of 32. So typing that in, 12,000 divided by tangent of 32. And there we are. Here's our answer. We're going to round our answer to the nearest 2 decimal places every single time. So here are 2 numbers after the decimal. You're going to look at the next number. That next number is not 5 or more, so it's not going to round up. It's going to stay as 0.01. So x is approximately, let's pull that back up. It's approximately 19,204.01. So 19,204.01. So that is our answer for x, approximately that amount. So now we can answer the question. It says, how far is the tower from a point directly beneath the plane? It is 19,204.01, and the units we're looking at here is, it says meters, okay? So 19,204.01 meters away, okay? Let's do a few more problems and then we'll wrap up the notes here. So let's look at the next one. See how the next one's going to be a little bit different. So number 3 says a flagpole has an 8.7 meter wire attached diagonally from the top of the pole to the ground. If the pole is 7.4 meters tall, what is the angle of elevation to the top of the pole? So here you're going to notice that they didn't give you a picture. Now we're going to have to draw the picture ourselves. This is where things start to become more difficult. So the first thing we're looking at is, well, I see we got a flagpole. Okay, so I'm going to draw a flagpole. Flagpole going to look something like this. There's our flagpole. And the next part says that it has an 8.7 meter wire that is attached diagonally from the top of the pole to the ground. So from the top of the pole, we have an 8.7 meter wire that is attached diagonally to the ground. So this is 8.7 meters, and it is attached diagonally to the ground. Okay, so we can complete our picture here. This black line is going to represent the ground. Now, the next part says if the pole is 7.4 meters tall, so the pole, the flagpole, this is 7.4 meters tall. What the question is asking now is, what is the angle of elevation to the top of the pole? Remember, angle of elevation is with a horizontal line and an upward line of sight. Here is your horizontal line, and here is your upward line of sight. They want to find out that angle of elevation, which is this angle right here, which we are labeling as X. So now that we've got our triangle labeled with the sides and what we're asked for, let's go ahead and fill in where that right angle is supposed to be located. It's supposed to be located here. And now we can start setting up our problem to use trigonometry to find this missing angle. So this is the angle of perspective we're looking at. The hypotenuse here is the 8.7. The 7.4 is the opposite. And then this would be the adjacent. What we have here is opposite and hypotenuse. So looking at SOHCAHTOA, we're working with the hypotenuse and the opposite. Which one has hypotenuse and opposite? This one, sine. So if we're going to set this up, let's go ahead and write out our ratio for sine. It's sine of theta is equal to, well, opposite over hypotenuse. Let's plug in our values for this particular triangle. So plugging in what we have sine of theta. Theta is the angle. The angle, we don't know what it is, it's x, so call it x. That's equal to opposite over hypotenuse. Well, opposite 7.4 over the hypotenuse, which is 8.7. And so now this problem is different than the one that we were looking at before. Now we're looking for the angle. When you're looking for the angle, this is whenever you are using that inverse trig. Inverse trig is the trig ratios that have the little -1 exponent. So if I want to solve for x here, what you're going to do is you're going to take the inverse sine of both sides. Doing this, we'll cancel this out, leaving us with the x by itself. X is equal to the sine inverse of 7.4 over 8.7. And now we just plug that into our calculator. That will be x, the angle of elevation for this problem. So we got sine inverse of 7.4 over 8.7. Let's type this in. Here is sine inverse. We got 7.4 over, let me type that in correctly here, 7.4 over 8.7. Looking at what we have here, we're going to round in the two numbers after the decimal. If I look at the next number, it's a 4, so it's not going to round up. It's going to stay the same, 58.27. So x is approximately 58.27. We can answer the question, what is the angle of elevation? Angle of elevation is what we got for x. It is approximately 58.27 degrees. So that represents our angle of elevation for this problem. So just be mindful of what they're asking you to find. If they ask you to find an angle, angle is going to be the problems where we're working with the inverse trig. If they ask you for an angle, you're doing inverse trig. If they ask you for a side, like we had in the last one, like if they asked us for this side length of x, this is where we put it over 1 and cross multiply. All right, let's look at the next one. Number 4 says a ship is sailing 3,280 feet above the ocean floor in search of sunken treasure. If the horizontal distance from the ship to sunken treasure is 4,000 feet, then what is the angle of depression from the boat to the sunken treasure? This one is one of the harder ones to draw. So let's break this up into chunks. It says that we have a ship sailing 3,280 feet above the ocean floor. I'm going to draw the ship. Here is our beautiful ship. And this ship is sailing. If it's sailing, it's on the ocean, right? Here's the ocean. And it tells us that it is sailing 3,280 feet above the ocean floor. So the ocean floor would be on the bottom. This means that the 3,280 tells us that's how far above the ocean floor it is. So that would mean that the ocean floor is located right here. And the next part tells us that if the horizontal distance from the ship to sunken treasure, so we got sunken treasure here. Sunken treasure, I'm going to just draw a box here with some treasure in there. It tells us that the horizontal distance from the ship to the sunken treasure is 4,000 feet. So horizontal is left to right. This distance is 4,000 feet. It's asking us now, then what is, let me use a different color here. Let's use purple. It says, what is the angle of depression from the boat to the sunken treasure? So from the boat to the sunken treasure means we're looking down, right? The angle of depression, please remember that your angle of depression is formed with a horizontal line and a downward line of sight. So in this particular scenario, I have to draw in my horizontal line. So I'm drawing this in as a dashed line. Your angle of depression that they want you to find is going to be located right here, x. Okay. Remember, angles of depression is formed with a horizontal line and a downward line of sight. But based off of what we said earlier, we said that, well, our angle of depression is congruent to the angle of elevation from the opposite point. So this would be the same thing as x right here. And this is how we can start to fill in the gaps in our triangle. Now we have the angle inside the triangle, and we're going to place our right angle right here. And now what we can take a look at is just the triangle that we're working with. This angle is x that we want to find. The bottom side is 4,000, and the vertical side is 3,280. If we're going to do trigonometry here, we're working with the two sides that are labeled would be the opposite and the adjacent. Okay. If we're working with trigonometry, this is when we're doing SOHCAHTOA. SOHCAHTOA is going to be us working for this problem, opposite and adjacent. Opposite and adjacent has tangent. So let's set this up. Our ratio for tangent, remember that's tangent of theta is equal to opposite over adjacent. Plug in our values in here. We got tangent of, well, theta is the angle, so x is equal to opposite over adjacent is 3,280 over 4,000. And we need to find x, right? So when we need to find x, when we need to find the angle, this is when we use the inverse trig. So we're going to take the inverse tangent of both sides. Taking the inverse tangent, tangents cancel, we're left with x is equal to the tangent inverse of, well, 3,280 over 4,000. And now we just plug that in. So plugging that in here, let's pull up our calculator. We have tangent inverse of, let's put that tangent inverse there, 3,280 over 4,000. What we'll see here is that the angle we get, if I'm rounding to the nearest two decimal places, 0.35, looking at the next number, if it's a 1, it's going to stay the same. It's not going to round up. So x is approximately, look at that number one more time here, 39.35. So we can now answer the question, what is the angle of depression from the boat to the sunken treasure? Remember, this is x and this is x. Okay. The angle of depression is what we got for x, approximately 39.35 degrees. Remember, angles are in degrees. Those are the units we look at for angles. All right. And so that represents the last problem in the notes. Okay. What I left here at the very end was just a problem that you're able to try with a partner. What I would suggest is give this problem a shot, try it, and then I would double check with the answer key of the notes that is posted on Canvas to see if you were able to get the correct answer. The idea for this one is that this is a multi-step problem, and it deals with you working with the angle of depression. I'm not going to solve this. The only thing I'm going to do is kind of just help walk you through the setup. So number 5, an observer at the top of a 50-meter tower. Here's our 50-meter tower. Notes that the angle of depression of a house lying due east. Here's east. East is to the right. So angle of depression of a house lying due east is 49 degrees. I just want to practice kind of labeling the angle of depression. Remember, angle of depression is with a horizontal line, so I have to draw it. So my angle of depression is 49 degrees. It's formed with a horizontal line and a downward line of sight. This is 49 degrees. And if that's 49, then this is 49. And then it says the angle of depression of a house lying due west, west is to the left, is 31 degrees. So angle of depression to the house lying due west is 31 degrees. So the angle of depression to this house is 31 degrees. So remember, angle of depression is formed with a horizontal line and a downward line of sight. Here's your horizontal line. Here's your downward line of sight. The 31 should be located here. Now, if this is 31, this angle right here is 31, right? And then it's asking you find the distance between the two houses. So we're going to find the distance here of x, and then you will find the distance of y. So the distance between these two houses, you're going to basically do trigonometry twice. looking at this right triangle, find x. Then looking at this right triangle, find y. Add them two together, and that'll give you the distance between the two houses. Like I said, give this problem a shot. Check with the answer key that's posted in Canvas of the notes to see if you're able to get the correct answer. But the key takeaway from this video, please be very careful when it comes to angle of depression. Remember that horizontal line has to be what's forming that angle of depression with the downward line of sight. All right.